Welcome back to the Data Analytics series. Today, we're diving into statistical inference and hypothesis testing. These concepts are crucial for making predictions and decisions based on your data. You'll learn how to define hypotheses, conduct hypothesis tests, and interpret the results to draw meaningful conclusions. We will be looking at the following contents in this video. Statistical inference refers to the process of making predictions or generalizations about a population based on a sample of data. In data analytics, we often don't have access to the entire population, so we rely on samples. By using methods such as hypothesis testing or estimation, we can infer the characteristics of the larger population and make data-driven decisions. The population represents the entire group you want to study, while a sample is a smaller, representative subset of that population. Statistical inference allows us to make conclusions about the population based on the analysis of the sample data. Hypothesis testing is a statistical method used to test assumptions or claims, known as hypotheses, about a population. By analyzing a sample, we can determine if there's enough evidence to support or reject a particular claim. In hypothesis testing, we begin with two opposing statements, the null hypothesis, or H0, which typically suggests no effect or no difference between groups, and the alternative hypothesis, or H1, which proposes there is an effect or a difference. Our objective is to assess whether there is enough evidence to reject the null hypothesis in favor of the alternative. The hypothesis testing process involves several key steps. First, you define the null and alternative hypotheses. Then, you select the significance level, typically denoted as alpha, which sets the threshold for how much uncertainty you're willing to accept. Next, you choose an appropriate test, such as a z-test or t-test. After running the test, you calculate the test statistic and p-value, which will guide your decision to either reject or fail to reject the null hypothesis. There are several types of hypothesis tests that are commonly used, each suited to different data and scenarios. The z-test is used when the population variance is known and the sample size is large. The t-test is suitable when the population variance is unknown or the sample size is small. The chi-square test is useful for categorical data, while ANOVA, or analysis of variance, is used to compare means across multiple groups. The z-test is calculated using this formula. Z equals the sample mean minus the population mean, divided by the population standard deviation, divided by the square root of the sample size. This test helps determine whether the sample mean is significantly different from the population mean. The t-test is similar to the z-test, but is used when the population variance is unknown. Instead, we use the sample standard deviation. The formula is t equals the sample mean minus the population mean, divided by the sample standard deviation over the square root of the sample size. There are two types of errors we can make in hypothesis testing. A type 1 error occurs when we reject the null hypothesis, even though it's actually true. This is also known as a false positive. A type 2 error happens when we fail to reject the null hypothesis, even though it's false, which is a false negative. Understanding these errors is critical in making informed decisions. The p-value is the probability of observing your test statistic, or something more extreme, assuming the null hypothesis is true. It helps determine whether the test results are statistically significant. If the p-value is less than the chosen significance level, often 0.05, you reject the null hypothesis, indicating that the results are unlikely to have occurred by chance. A confidence interval gives you a range of values within which the population parameter is likely to fall based on the sample data. For example, a 95% confidence interval means that 95 times out of 100, the true population mean will fall within this range. Confidence intervals offer another way to make inferences about the population. Let's say you want to test whether the average salary in your company differs from the national average. You collect a sample of 30 employees, and the average salary in your sample is $60,000 with a standard deviation of $5,000. The national average is $55,000. Using a one-sample t-test, you can test whether the difference is statistically significant. That wraps up our discussion on statistical inference and hypothesis testing. In the next video, we'll move into regression analysis, a powerful tool for predicting and forecasting data. If you found this tutorial helpful, be sure to subscribe and hit the notification bell to stay updated with our latest content.
See you next time.